Therefore, a square equal to cos 2 theta sin 2 theta minus sin 2 theta cos 2 theta. Now this is of the form cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B, that means cos of A plus B. Now for the second element, we multiply these three entries corresponding or with the entries of the second column, 2 into 0 plus 0 into 3 plus 0 into 0, that means 0. Actually, I am discussing those sums which are useful to the students of 11 and 12 standard. Though I have not discussed yet the topic permutation and combination, I have taken one sum. Now fourth sum, if A equal to matrix, elements along the first row cos theta sin theta, elements or entries in the second row minus sin theta cos theta. Then we have to prove this one. Here A to the power A, that means product of n numbers of matrices A. That is why the basic step will be for n equal to 2. We have to start taking n equal to 2. Now we start like this. Let Pn where A equal to for n equal to 2. A square is equal to, we have to multiply 2 A's, cos theta sin theta minus sin theta cos theta into cos theta sin theta minus sin theta cos theta. In the earlier episode, I have discussed how to multiply two matrices. Now I write here the result. We multiply row column wise, and that is why we put the symbols like this. Then in the first row, cos square theta plus sin square theta, cos square theta minus sin square theta, cos square theta minus sin square theta. That is the first element of the first row. Then cos theta sin theta plus sin theta cos theta. This element into this element, which gives cos square theta. Then this element into this element minus sin square theta. Then for this second element in the first row, cos theta into sin theta plus sin theta into cos theta, we get this one. Then for the second row, minus sin theta into cos theta means minus sin theta cos theta plus this into this, that means minus sin theta cos theta. And for the second element, minus sin theta into sin theta minus sin square theta, then cos theta into cos theta plus cos square theta. This sum is very useful for the 12th standard student. Then already you have learned cos 2 theta equal to cos square theta minus sin square theta. Therefore this will be cos 2 theta, and this is 2 sin theta cos theta, means sin 2 theta, and this is minus 2 sin theta, minus sin 2 theta minus sin 2 theta minus 2 sin theta cos theta means minus sin 2 theta, and this is cos 2 theta. Therefore, a square equal to cos 2 theta sin 2 theta minus sin 2 theta cos 2 theta. And from here, or this one, also from e to the power n cos n theta sin n theta minus sin n theta cos n theta, we have a square equal to cos 2 theta sin 2 theta minus sin 2 theta cos 2 theta. By actual multiplication, we have got a square equal to this one, and from this one, a square will be this one. Therefore, the immediate conclusion will be P2 is true. Now, I am to run. Those students who are interested, I think they are noting down. Let Pm be true, that is a to the power m is equal to cos m theta sin m theta minus sin m theta cos m theta. For here, of course, m greater than 2, m is natural number. For Pm plus 1, already it is mentioned that we have to show by actual calculation a m plus 1 is equal to into a. Already for this we have this one cos m theta sin m theta minus sin m theta cos m theta into cos theta sin theta minus sin theta cos theta. Now the multiplication we multiply and write the product cos m theta cos theta minus sin m theta cos m theta sin theta plus sin m theta cos theta. This into this plus this into this. Next we have got this one by multiplying cos m theta with sin theta plus sin m theta cos theta. For the second row, minus sin m theta cos theta plus cos m theta cos theta. Sin m theta cos theta cos m theta, sorry, minus. I have written wrongly. This will be sin theta and minus sin m theta plus cos m theta cos theta. Now this is of the form cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. That means cos of A plus B. Cos m plus 1 theta, and this is cos A sin B plus sin A cos B, or sin A cos B plus cos A sin B form, that is sin m plus 1 theta. This is sin m plus 1 theta cos of m plus 1 theta. Now you follow, this is formed. If we consider this one, just we have replaced, or this one replaced m by m plus 1. That means the conclusion will be or which is obtained, I write like this, which is obtained by replacing m by m plus 1 in, say I write it as 1, sorry, this one, in 1. Not this one. Therefore, to finish, I just rub this part. Therefore, immediate conclusion will be P m plus 1 is true. Therefore, by PMI, Pn is true. N belongs to set of natural numbers. Therefore, final step, a to the power n is equal to cos n theta sin n theta minus sin n theta cos n theta, where n belongs to set of natural numbers. One thing, if we put n equal to 1, we get this one, but that is not the case of product. Therefore, in this case, we mention n greater than equal to 2. The problem is finished. Sum A is a square matrix, third order square matrix rather, then a to the power n is this one. In this case also we have to start taking the least value n equal to 2. Now let Pn a to the power n, 2 to the power n, 0, 0, 0, 3 to the power n, 0, 0, 0, 5 to the power n. For n equal to 2, LHS is s square. That means product of two a's. I take the product into for the product of two matrices. You show the steps on the right side like this. I discuss like this for first row, then for second row, then for third row. For first row, first element will be 2 into 2, others are 0. Therefore, 2. Then for the second element, that will be 0, and third element will also be 0. I discuss like this. We use row column wise multiplication. 2 into 2, that is 2 square, 0. These two are zeros, therefore remaining will be 0. The first element is this one, that is equal to 2 square. Now for the second element, we multiply these 3 entries corresponding or with the entries of the second column. 2 into 0 plus 0 into 3 plus 0 into 0, that means 0. And for the third element in the first row, 2 into 0 plus 0 into 0 plus 0 into 5, result will be 0. Then for the second row, elements of second row, we have to consider the second row first with the first column, that will be 0, as 0 into 0 plus 3, 0 into 0 plus 3 into 3, that means 3 square. 0, that will be in the second column. Here 3 products are 0, therefore 0 plus 0 plus 0 means 0. Then for the second element, 0 into 0 plus 3 into 3, that means 0 plus 3 square plus 0, that is equal to 3 square. And for the third element, 0 plus 0 plus 0 equal to 0. Now for the third row, you see I have mentioned first R1, that means first row, then R2 means second row, then R3 means third row. The first element will be 0 plus 0 plus 0 means 0, then 0 plus 0 plus 0 equal to 0, then 0 plus 0 plus 5 square equal to 5 square. Means result is 2 square 0 0 0 3 square 0 0 0 5 square. Students or learner, you follow. Actually, this sum is for 12th standard students. As I have not discussed yet matrix determinant, the product of matrices will be like this. Thus, LHS this and RHS is equal to, just we have to replace n by 2, 2 square, 0 0 0 3 square, 0 0 0 5 square. Therefore, LHS equal to RHS, which implies P2 is 2. Now, inductive hypothesis as well as inductive step. Already I have mentioned. No need of mentioning those steps. You just follow like this. Then let Pn be true. This is inductive hypothesis. E to the power n is equal to 2 to the power m 0 0 0 3 to the power m 0 0 0 5 to the power m. Now we shall show by actual calculation Pm plus 1 whether it is true or false. For Pm plus 1, a to the power m plus 1, that is equal to a to the power m into a. Now a to the power m already we have assumed this one. We write that 2 to the power m 0 0 0 3 to the power m 0 0 0 5 to the power m into 2 0 0 0 3 0 0 0 5. Now the multiplication row column wise 2 to the power m into 2, that means 2 to the power m plus 1, others will be 0. Then for the second row 0 3 to the power m plus 1 0 0 0 5 to the power m plus 1. Which is obtained from I take this step as 1. Already I have discussed earlier. From 1, by replacing m by m plus 1 in RHS of 1. Follow that. By actual multiplication we have got this result, and this will be obtained if we replace m by m plus 1 in 1. Therefore, comment is p m plus 1 is true. And don't forget to mention here m greater than equal to 2, m is natural number. Therefore, by PMI, principle of mathematical induction, in short, Pn is true. Therefore, we write the final step. A to the power n is this, where a equal to 2, 0, 0, 0, 3, 0, 0, 0, 5 root. Remember one thing, a to the power n already I have discussed, just I repeat. A to the power n means product of n numbers of a. Therefore, you cannot take n equal to 1. Though you can verify, putting n equal to 1, we are getting that original matrix. But that is useless, as e to the power n indicates product of n number of a's. Therefore, for basic step, we must take n equal to 2. Therefore, the sum is finished. Also, I am going to finish this topic. Already I have worked out variety of sums. Those are useful for class 11 and 12.